In this video, I'll introduce the entity grid model. I'll provide some background intuition and then show how it can be used to compute probabilities for different transitions between entities. The entity grid model is another way to capture entity-based coherence based on patterns in the way that entities are mentioned. The approach is based on an entity grid, which is a two-dimensional representation of the distribution of entity mentions across sentences. Rows in the grid correspond to sentences, and columns in the grid correspond to different entities in the discourse. The values in the cells of the grid correspond to the entity's grammatical role. It might be used as a subject, an object, or neither, or it might not be present in the sentence at all. For example, let's say we have 4 sentences, and some automated algorithm has identified what it thinks are the entities in those sentences and run them through a parser to determine the grammatical roles of those entities. Our 4 sentences are similar to what we saw in our previous video. If you're watching these videos out of order, you may want to watch the video on centering theory for a refresher. So we have Natalie was an assistant professor at UIC. Natalie taught a class at UIC called Natural Language Processing. Natalie enjoyed teaching the class because Natalie liked NLP a lot. Natalie was planning to teach the class once per year. We create an empty grid containing 4 rows, one for each sentence, and a column for each entity contained in those 4 sentences. Then we go ahead and start filling in the values in that grid. We'll start with the first sentence. So we see that the sentence includes the entity Natalie, and it's acting as a subject, so we put an S in the grid. It also includes the entity UIC, which isn't acting as a subject or an object, so we put an X in the grid. It's not including the entity's class or NLP. In the next sentence, we have the entities Natalie acting as a subject, class acting as an object, and UIC acting as neither. We fill the values for those entities using an S, O, and X respectively, and then indicate that the entity NLP does not exist in the sentence. In the third sentence, we see the entities Natalie, class, and NLP, and we go ahead and fill in those values with S, X, and O respectively, and indicate that the entity UIC is not present. And finally, for the last row, we check the 4th sentence and we see that Natalie is present as a subject and class is present as neither a subject nor an object, but neither UIC nor NLP are present, so we fill the cells in the grid accordingly. So at this point, we've filled out our entity grid. Now that we have our entity grid, we can use it to learn about the entities and their transitions in the context of these 4 sentences. For example, dense columns, or columns where almost all of the values are filled, indicate entities that are mentioned frequently. In our case, the column for the entity Natalie was very dense, so that was a frequently mentioned entity. Sparse columns indicate entities that are mentioned more rarely. NLP is a good example of an infrequently mentioned entity from our 4 sentences. The transitions within columns from one value to another indicate local entity transitions. For example, an entity might be a subject in one sentence, but then transition to being an object in the next sentence. The entity grid model measures coherence based on patterns in these local entity transitions, where each possible transition ends up with a probability. We can assign probabilities to the transition patterns spanning entire columns or just parts of them. For example, we could compute the transition probability of seeing 2 X's followed by 2 dashes. In this case, there are 4 possible transitions of length 4, and only one of them matches the pattern XX dash dash, so the probability associated with this transition is 1/4. We could likewise compute the transition probability for seeing a dash followed by an O. In this case, in each column, there are 3 possible transitions of length 2. There's a transition from sentence 1 to sentence 2, a transition from sentence 2 to sentence 3, and a transition from sentence 3 to sentence 4. There are 4 columns in the grid, so this means that there are 12 possible transitions of length 2 in the grid. Of those 12 transitions, 2 of them are cases where a dash is followed by an O. So the probability associated with this transition is 2/12 or 1/6. We compute the probabilities for each transition in our entity grid, as shown in the previous example, and then we can use those transition probabilities as features in a machine learning model that learns to predict coherence scores. This can be done in a self-supervised manner if we don't have manually assigned coherence scores. For example, we can take a corpus of text from some source that is expected to be coherent, maybe a peer-reviewed article or a published work of fiction, for example. We can assume that the sentences in that source are ordered coherently. Then, we can jumble up the sentences and assume that after jumbling them up, they're ordered incoherently. The machine learning model can then learn to distinguish the natural transition patterns from the modified ones, in turn predicting coherence.